This is Honors Algebra 2 Pre-Calculus. We're doing 9.7 in Pre-Calc, which is probability. Example 5. A lottery ticket has 6 different numbers from 1 to 30. What is the probability that you win on a single ticket? So this is one of those problems where it's definitely not worth us writing out the sample space. There's a reason it's difficult to win the lottery. You're not going to write out all of the possible outcomes. That would be crazy. So a couple things to keep in mind. The order of the numbers on the lottery ticket don't matter, because they're always put in ascending numerical order. So it doesn't matter what order the balls come out of the machine when they're drawing the lottery. The order doesn't matter. Now that's not the case if you're talking about something like where there's a Powerball number or something that's like a different special number, but that's not this. This is just, hey, there are 6 numbers and they're listed in ascending order. So what we're looking at here is a situation where the order of the numbers doesn't matter. So if we want the number of items in this sample space, what we're going to do is we're going to do 30, choose 6. We pick the NCR because this is a combination. Order doesn't matter. So this is going to be 30 factorial divided by 30 minus 6 factorial, which would be a 24 factorial, times 6 factorial, right? So this is going to be a really big number. If you could try typing in your calculator, that's fine. The other way to do it is to recognize that this is actually 30 times 29 times 28 times 27 times 26 times 25. And then the 24 factorials are going to cancel. And that makes this a little bit more doable. So the 24 factorials cancel. And on the bottom, you have 6 times 5 times 4 times 3 times 2 times 1, which you can actually cancel a bunch of this stuff. I would probably use the 6 and the 5 to immediately cancel the 30. And then you could cancel some other stuff out if you want, or you could divide all of it by 24. It doesn't really matter. So essentially what happens is if you write all of this stuff out, right, you're going to end up getting, so I don't care if you type it in like this or if you type in this information here. We'll actually see if the calculator is going to let me type in the 30 factorial over the 24 factorial. There's a good chance that it's going to overflow. So overflow is just when there's a number that's too big for your calculator. It did let me type it in. So if you didn't want to do all the simplifying stuff, you could just type it in. What you're going to get is that the number of items in the sample space is 593,775, which, by the way, is why the lottery uses way more numbers and combinations than this. Okay, so that's the total number of items, and you're only buying one ticket, right? So the number of favorable outcomes is that one chance that the one ticket you bought wins. So the probability that you win, right, is going to be 1 over this 593,775. Or if you want to go ahead and type that in your calculator to get a rough idea of how unlikely it is. And again, this is actually more generous than the real lottery, but this is a 1.684 times 10 to the negative 6. So anybody who forgets what that means that you take this decimal place, so this 1.684, you're going to move this 1, 2, 3, 4, 5, 6, right? So that means that you have a 0.0001684% chance. And that's, again, more forgiving than the real lottery. So just to point out why the lottery is a rough thing to win.